Hello and welcome to another video of network security series. In this video, I'm going to talk about the classical encryption methods or the traditional encryption techniques that were used in the history for the purpose of cryptography or for the purpose of secure communication. Here is a brief roadmap of today's presentation. We will study different types of encryption techniques. The two most common techniques are substitution cipher and transposition ciphers, and then some examples of different classical encryption techniques. Before going to study the techniques, let me tell you what are those classical encryption techniques or when they were used. Actually, the cryptography has a very long but a very colorful history, and it goes back to thousands of years ago. You will see that the history is filled with examples where people tried to keep information secret from adversaries. Historically, four different types of people they have used to secure their communication, or you can say they contributed to the art of cryptography. And these four groups of people were military, diplomatic persons, uh, diarists, and the lovers. They use cryptographic technique in order to communicate with their troops, with the person they loved, and with the diplomatic persons. Like the kings and generals, they always communicated with their troops by using basic cryptographic methods, and they used them to prevent the enemy from learning about the sensitive military information. So the classical encryption methods, although they are rarely used these days, however, they give a good illustration understanding of several important ideas of cryptology. We do not use them because they become so weak in today's modern world, but still we are going to study them because they are interested and they provide us a basic background of the field. Okay, the classical ciphers, they are actually very simple. That is why they are very vulnerable to be break with modern technologies. Even many of them, they are breakable if the attacker only knows very little information about the cipher text. So let us see some of these classical techniques. We can divide the classical encryption techniques into two types. The first one is substitution cipher and the second one is transposition cipher. Let us see what is substitution cipher. Actually, the substitution cipher, they are probably the most common form of cipher. What happens here? In substitution cipher, each letter of the plain text, I'm sure you know now you have the knowledge of plain text. So each letter of the plain text that is replaced throughout the message with another letter. So you actually replace letters with some other letters, like A is replaced with D, B is replaced with F, C is replaced with Y, and things like that. Substitution cipher, they are often suspicious, or you can say they are easy to break with a technique which is known as frequency analysis. When we will study different types of attacks, there we will see what is a frequency analysis attack. But for now, you can search on the internet that every letter of the English alphabets like ABC, they have different frequencies, how frequently we use them in our conversation. Some have higher frequency, other have low frequency. So by using the analysis, you actually find the frequencies of the letter in order to break the text, the cipher text, or in order to convert the cipher text into plain text. So substitution cipher, they actually use a very simple technique for encryption, and that technique is to replace the letters with some other letters. Okay, they are further divided into two categories. One is known as monoalphabetic substitution cipher, and the second one is known as polyalphabetic substitution cipher. And there is a very minor difference between these two. In the first one, which is also known as simple substitution cipher, uh, it actually depends on the fixed replacement structure. That is, each letter of the plain text will be replaced with the same letter throughout the text. If you have a letter, for example, divided, and you want to replace D with F in your text, then once you encounter D, you replace it with F. Later on, again you find D and you replace it with F. Again D and you replace it with F. This technique is known as monoalphabetic substitution cipher, where D is encrypted to F. Every time we see the letter D in the word, in the plain text, we replace it with F. And an example of monoalphabetic substitution is Caesar cipher, which we will see in a moment. On the other side, polyalphabetic substitution cipher is a bit different. Each plain text letter maps to a different random cipher letter, and it prevents the simple frequency analysis attack that we just studied. And an example of this is visionary cipher. So if you want to encrypt this divided word by using polyalphabetic substitution cipher, then here maybe you replace D with F, but later on maybe you replace D with G, and for the third time maybe you replace it with H. Now if you are using different letters for the same letter in order to convert it into ciphertext, then such technique is known as polyalphabetic substitution cipher. Now let us see about the second category of substitution cipher, of the encryption technique, which is known as transposition cipher. We have two categories, substitution and transposition. In substitution, we have two subcategories, mono and poly. Now transposition cipher. If you recall the substitution ciphers, they actually replace each letter with a different letter to produce the cipher text. While in case of transposition cipher, the letters of the plain text, they are just move around. Means we are not actually using the replacement strategy here. We are actually, what we are doing is that we are moving the positions. We are changing the positions, the locations of the letters in the plain text, right? The letters of the plain text are recorded in some way fixed by a rule which is known as a key. So in transposition ciphers, we will change the positions of the letters, but for changing the position, we will need a key, right? And here we have a simple example. For example, you have the plain text hello world, and you want to convert it into a cipher text by using the transposition cipher method, then it would become like this. Now, what is the technique that we have used here? We actually replaced, you can say we revert the whole text here. Okay, like we have a plain text word hello. So O, then L, then the second L, then the E, and then the H. Revert order. If you write it in the revert order, then it will become an example of the transposition cipher. This is a very simple example, by the way. We will see some more examples in the coming slides about the transposition cipher. So here you see we do not use any replacement strategy. We actually use the revert strategy, the changing of the location or the position of the individual letters in the plain text in order to generate the cipher text, right? Now let us study some basic classical cipher techniques. The first one is known as Atbash cipher. This is the first example of our list. It is one of the earliest known and very simple substitution cipher. It is simple nowadays, but I am sure at that times it would be difficult for the people to break communication which were encrypted by using the Atbash cipher. And it is an example of a substitution cipher. Why it is a substitution cipher? Because we will see that we have to replace the letters with some other letters. The basic technique of this cipher is that simply reverse the plain text alphabet to create the cipher text alphabet. Okay, reverse technique. How? All the A's will be replaced by Z. All B's will be replaced by Y. All C's will be replaced by X, and so on. Although this is a very weak substitution cipher, since there is no secret key behind the generation of the cipher text alphabets to perform the encryption, right? So this is very weak cipher. Let us see an example of the 8-bit cipher. As I just mentioned, every time you encounter A in the plain text, it will be replaced by Z. B will be replaced by Y. C will be replaced by X. And this is like a fixed rule. For all the cipherment, for all the conversion of plain text into ciphertext, you have to follow this rule. And this example, this classical encryption method is known as Atbash cipher. For example, you have a plain text, this is a secret message, and you want to encrypt it by using the Atbash cipher. Then you have to convert T. T will be replaced by G. H will be replaced by S. I will be replaced by R, and S will be replaced by H. Now, if you want to write a secret message to someone, you can just send this message, which is an example of a cipher text. But your receiver must know how to convert this cipher text into plain text, or how to derive the plain text from this cipher text, or how to recover the plain text from the cipher text. Okay, all the encryption techniques that we are going to study in this lecture, we will be focusing only on encryption technique, but decryption process is the opposite. If you want to derive the plain text from this cipher text, you have to apply the same process in reverse order. Go for the cipher text letter G, which is here, and see the appropriate plain text letter, there is T. So G will be converted into T. Now go to the cipher text column, search for S, see the appropriate plain text letter, that is H. Again search for R and see the appropriate plain text letter, there is I. Now go for H, search for the appropriate plain text alphabet or letter, there is S. You see, we have recovered the plain text from the cipher text at the receiver side. So only here at the Atbash cipher, we replace each letter with the appropriate letter in the ciphertext, and on the receiver side, we actually derive the plain text in a similar way but in reverse process. So this is an example of a classical encryption method. The second example that we are going to study is known as Polybius cipher, and it is an example of a Greek cryptography. Actually, they use a square table that allows someone to translate letters into number. This is again an example of substitution cipher, but here, in order to convert the letters of the plain text into cipher text, we have to rely on a table. What the table has? The table has all the 26 letters of the alphabets, of the English alphabets from A to Z. One thing that is important to remember about this table is that as we have only 25 cells, but the total number of letters are 26, so I and J will actually occupy the same cell. You can also combine any other two letters in the same cell instead of IJ, but the proper way, the classical way, is to combine I and J. So you see, there are 25 cells in this table, and the letter I, R, and J are usually combined. In the Polybius cipher, each letter is replaced by the position in which it appears in the square in the cell. But first you have to use the row and then you have to use the column. And the intersection of the row and column will give you the letter which is going to be used for the replacement. And to decipher a message, you actually find the letter here and then find the appropriate position, like the intersection of the rows and columns. Again, we are going to focus only on the encryption process. For example, you have a plain text given like this. This is easy. And you want to convert this plain text into ciphertext by using the Polybius cipher method. So take the first letter as an example. There is T. Okay. Where is T? Here we have the T. Now first record the row in which this T is. Row number 4. And then the column number. Column is also 4. So instead of sending T, you have to send 44. Take the next alphabet, H. Where is H? Locate H. H is here. First find the row. The row number is 2. And the column here is 3. So 23 is the replacement letters for H. Now I. Here we have I. Row is 2 and column is 4. 2, 4. And same with the other letters. So you see, Polybius cipher actually uses a table to convert the plain text into ciphertext. The table has all the alphabets written. I and J are combined. In order to convert plain text letter alphabet into ciphertext, we go into the appropriate cell. We record the row number first and then the column number and then transmit it. On the receiver side, the receiver will need to recover the plain text from this ciphertext. The process is opposite but simple. What the receiver will receive, 44, 23, 24, 43 and so on. So in order to decrypt 44, the receiver knows the technique used for the encryption. So first he will consult row number 4 and then column number 4. And the intersection of these two, the letter is T. So T will be recovered. In order to recover the next plain text letter, consult the ciphertext. That is 23, which means row number 2 and column number 3. And the intersection of these two will give you the letter H. So H will be recovered from this ciphertext and so on. This is Polybius cipher. This cipher has the disadvantage of doubling the length of the message. You see, for every plain text letter you required 2 ciphertext letter. There is a disadvantage. But it is still a special case of substitution cipher. And inside substitution cipher, we study 2 different types of cipher, mono and poly. This is actually an example of monoalphabetic substitution cipher, because every time the letter is going to be replaced by the same row and column. Okay. Our next example of the classical substitution technique is known as Pigpen cipher. This is very interesting, by the way. And this is another example of substitution cipher. And this scheme was developed long ago. I think it was developed in 70s. The exact year is not known to me, but in 70s. And it was used for record keeping and corresponding. Sometimes this technique is also known as Masonic cipher. Here the technique is a bit different. Instead of replacing the plain text letters with another letters or numbers, we actually replace the letters with symbols. This is interesting. Instead of replacing the letters with other letters, ABC, or with numbers 1, 2, 3, as just we saw, the plain text letters are replaced by symbols. To encrypt a message, each occurrence of a letter is replaced with a designated symbol. We have A, B, C up to Z, and they are represented in different ways, like this. This is the standard used for Pigpen cipher. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, and then rest of the letters. Okay. The symbols are assigned to letters using the key shown below. This is the key. And the letters is replaced by the part of the image. For example, if you want to send A, if you want to convert the plain text A into ciphertext, then you have to use the symbol. What is that symbol? The symbol for A is this one. You see, this is the symbol for A. Let us consider M. Now this is the symbol for M along with the colored circle. You see, this is how we represent M. T could be represented like this. Okay, W will be represented like this. So every letter has a corresponding symbol which is unique for representation of that letter. Instead of sending the plain text, we send this cipher text towards the receiver, and then the receiver know how to decrypt this message, how to recover the plain text from this cipher text, because the key is known to sender as well as to the receiver. So if in order to recover A, this symbol, he will go and search for this symbol, and then the letter, the alphabet there is A. So A will be recovered, then M will be recovered, and things like that. So the decryption process is just the reverse of the encryption process. You have to use the same key, that is this grid. You locate the image in the cipher text and then replace it with the letter given in that part of the grid. This is Pigpen cipher. Our next cipher is none other than the Caesar cipher, which is the most widely known encryption technique in the history of cryptography. Some of the security related person, when they are going to teach the classical encryption techniques, they actually start from the Caesar cipher, because this is one of the most widely known encryption technique, and it was developed by Julius Caesar around 58 BC. This technique is also known as shift cipher. Originally, it was used by the Caesar for sending encrypted messages to his troops. Remember the four categories. One of them is the army, the military person. So it was used inside the military to send messages by the commander to the troops. And it is an example of the substitution cipher, and inside the substitution cipher, it is the monoalphabetic cipher. Each letter here is replaced by the third letter to follow it. The third letter. For example, if you want to encrypt A, then add 3 with the A. So A will always be replaced with D, B will always be replaced with E, and then F, and then D will be replaced with G, and so on for the rest of the letters. The key in this algorithm is actually the number by which we shift the alphabets. Normally he used the word the key 3, but you can use any key. You can replace A with E, for example, or with F, for example, or with G, or with H, or with I, or with J. Depends on the number, which is the key, which is the secret. Okay, so if you want to send a message by using the Caesar cipher to your friend, you have to tell him or her the key. Hey, I have encrypted this message by using the key, for example, 5. And then it will help the person to decrypt the message or recover the plain text from the ciphertext. To facilitate the Caesar cipher encryption, we actually use something which is known as cipher wheel. Okay, here in this example, we have used a key of 5. So you can see this is our inside the circle we have the plain text, and outside the circle we have the ciphertext letters. Okay, so sorry, outside we have the plain text, and inside the circle we have the ciphertext. So our first plain text letter is A. A plus 5. What you will get? B, C, D, E, F. So A will always be replaced with F. And then you write the rest of the letters. B will be replaced with G, C will be replaced with H, and so on. So we have an example. Send cache. If you want to send this plain text in encrypted form, if you want to encrypt it by using Caesar cipher, then the generated cipher text is like this. How we generate it? By using the key 5. S. Go for S. S will be replaced with X. E will be replaced with J. N will be replaced with S. And D will be replaced with I. So if you send this message to someone, this is in ununderstandable form. And this is what cryptography tell us. We are actually not hiding the existing of the information of the data. Data is still there, but it is in an understandable form. Okay, this is about Caesar cipher. Our next example is known as Playfair cipher. Okay, let me tell you one thing. The techniques that we are studying are not the only techniques. We also have some other techniques available, but we will not be able to cover all of them. So some of the techniques like the like the Vaginary cipher and like the B4 cipher, I am going to ignore them for this class. So the next one in our category is the Playfair cipher. It was invented by Wheatstone in 1854. Actually, the name of this cipher is related with the name of the friend of the developer of this cipher. His friend name was Playfair, so he gave it a name. He gave his solution the name of his friend. Okay, it was used as a standard by the British Army in World War One, and also US Army and other allied forces, they use it in World War Two. If it is used in world wars, which means this is something which was unbreakable at that time. Or you can say it is more secure as compared to the other classical encryption technique. That is why it was used by armies during world wars. Actually, in Playfair cipher, we encrypt pair of letters. The examples that we saw until now, we encrypt individual letters. Here we have to encrypt pair of letters, and those pair of letters are known as digraphs. So the first point about Playfair cipher is that we have to encrypt pair of letters. They are known as digraph instead of single letters. And this is significantly hard to break, especially at that time. Like the previous one which I explained, it was like the Polybius cipher, in which we use a table of 5 by 5. We have to use a table or a matrix of 5 by 5 like this. Remember the cells of the tables, something like that. So we have to use a matrix of 5 by 5 for the letters. Okay, and then beside from that, we will use something which is known as a keyword, or you can say the secret key. So the second point is that we have to use a matrix of 5 by 5, and the third point is that we have to use a keyword as well, which is going to be our key, our secret. Now the question is how we will actually construct this 5 by 5 matrix, how it will be constituted. We have to fill the letters of the keywords in that table. But remember, if a letter appears 2 times in the keyword, you have to write that letter only once. Duplications are not allowed. Another rule for filling the matrix is that you have to fill the matrix from left to right and from top to bottom. Once the key is finished, you will have to write the rest of the alphabets in the keys. Let me show you an example to make things simple. First, you need a matrix that is going to be 5 by 5, like 1, 2, 3, 4, 5, 5 rows and 5 columns. The table will be empty initially, there will be nothing. Then you have to use the keyword. In this case, the keyword is monarchy. Now you have to write this keyword in this metric, starting from left to right and from top to bottom. But the rule is that if this contain any letter more than once, then you have to ignore the duplicates. So M appears only one, O appears only one, N appears only once, A appears only once, R appears only once, C appears only, all the letters appears only one. So you have to write it like this, left to right, monarch, and then top to bottom, and again left to right, monarchy. So the first thing is to write the keyword or the key or the secret. After writing the, the keyword, you have to fill the rest of the cells with the remaining letters. So starting from A, we already have write the A. So the next letter to consider is B. Do we have B here? No. Write that. Next letter is C. Already written. Next letter is D. Write it. Then E. Then F. Duplicate is not allowed. G. H is already there. So we do not need to write it again. I and J, remember from the previous example, from the previous substitution technique, you have to write them combined in a single cell, and then rest of the letters. So all the letters, 25, 26 letters are there adjusted in the 26, in the 25 matrix. 5 by 5 will give you 25 cells. Now, this is only the one half of this story. We have a keyword, we have a 5 by 5 matrix. What next? We need our plain text. And to encrypt the plain text into cipher text, we have to consider two letters at a time. But there are certain rules. You can study these rules later on. I will try to explain these rules by using an example. These are the rules for converting plain text letters into cipher text letters. Okay, let us see an example. We want to encrypt the plain text, hide the gold in the tree stump by using the Playfair cipher. Two things are required: a keyword and a metric, 5 by 5 metric. So the keyword is Playfair example. First thing you need to do is to write this keyword in this matrix from left to right and from top to bottom, avoiding the duplicates. For example, A appears 2 times, you have to write it only once. And once you write the example, the keyword Playfair example, which will end up to here, you have to fill the rest of the cells with the remaining characters. Okay, B, C, D, G. Do not write J. J will be written over here along with I. Okay. So once you did this thing, the next step is to convert this given plain text into cipher text. According to rule number 1, you have to divide this given plain text into two. Remember, we are interested in encrypting two letters at the same time, not a single. So the first couple of letter is H, I, and D, E. This is H, I, D, E, T, H, and so on. Okay. So according to the first rule, you have to search for same letters in the same cell. Okay, our plain text is height. The first word is height. Make couples, make group of two letters. So the first group is HI, the second group is DE. You see, HIDE. And then do the same thing for the rest of the letters. There are chances that the last cell will contain only a single letter, but we need two. We have to resolve it. First, apply rule number one. Rule number one, what is it? According to rule number one, you have to go through each cell to find if there is any cell where there are two letters which are the same. HI different, okay. DE is different. TH are different letters, different letters, different letters, different letters, different letters. Stop here. We have found a cell where two letters are the same. Now in this case you have to apply rule number one. According to rule number one, you have to replace the second letter with X, and this letter will be combined with the next letter. There is S, ES. Then T will be combined with U, TU. M will be combined with P, MP. So according to rule number one, you will study it. If a digraph consists of the same letter in the same cell, what you need to do? You need to put an X instead of the second letter. And also according to rule number one, if the last cell contain a single letter, then you have to use the X there as well. Now we have applied rule number one. Okay. Next, we have to go towards rule number B. What we are doing, we are actually converting the plain text into cipher text by using the Playfair cipher. We have already applied rule number one. There are four rules. According to rule number two, the plain text letter fall if they fall in the same row or let me explain it with the help of an example. The next step is that we have to convert all these plain text into cipher text, but for that we have to follow certain rules. Take the first cell letters, there is HI. Our digraph is HI. Our square metric 5 by 5 is mentioned here. Okay, so you have to search whether we need to apply rule number 2, rule number 3, or rule number 4. What are these rules? To summarize these rules, according to rule number 2, you have to apply rule number 2 if both the letters are in the same row. You have to apply rule number 3 if both the letters are in the same column. And you have to apply rule number 4 if they are in different column. So remember, rule number 1, you need to apply it only once at the beginning of forming the pairs of letters. And then depending on the situation, either you have to apply rule number 2 or 3 or 4. If they are in the same rows, apply rule number 2. If they are in the same column, apply rule number 3. And if they are in the opposite, if they are in the different rows and column, then apply rule number 4. Now see H. Where is H? H is here. Where is I? I is here. Are they in the same row? No. Are they in the same column? No. Are they in different rows and column? Yes. So they are in the different rows and column. Which rule will be applied on them? Rule number 4. And according to rule number 4, what will happen here? If the letters are on different rows and different columns, each plain text letter in this pair, they will be replaced by the letters that lies in its own row and the column occupied by the second plain text letter. For example, we want to replace H with a cipher text. So follow the same row and the column in which the second letter is, that is I, and the intersections of these two is B. So H will be encrypted into B. Now the same procedure for I. Follow the same rule, and the column in which the second letter is, there is H, and the intersection of these two is M. So I will be replaced with M. Our cipher text for high is BM. And you have to do the same process for the rest of the digraphs. Our next digraph is DE. For example, now DE, let me show you this example as well. D and E. First thing you need to do is to find whether rule number 2 will be applied, rule number 3, or rule number 4. Okay, so search for D. D is here. And search for E. I think this is E. Yes, E is here. They are in the same column. If they are in the same column, which rule will be applied? Rule number 3. So now you have to apply rule number 3 to encrypt this second digraph. What is rule number 3? According to rule number 3, if the plain text letter falls in the same column, then replace them with the letter immediately below them. E will be replaced, D will be replaced by O, and E will be replaced by D. That is the rule. If a letter is here, then it will be replaced by the letter above it. Okay, so now we need to encrypt D and E. They are in the same column. Rule number 3, D will be replaced by O and E will be replaced by D. Okay, and same you can practice the rest of the plain text by using the same rules. This is how Playfair cipher convert a plain text into cipher text, and that is why it was used in word walls, because it is too much secure. The technique is very much secure. Okay, and for the decryption the process is opposite, but we will not go into the details. Our next example is Ralph's cipher, and it is actually an easy to apply cipher. But why it is here in the list? Because it is the first example of the transposition cipher. Remember, in the transposition cipher we actually not replacing the text, we are actually jumbling up the letters, moving up the letters, changing the positions of the letters in a message. Okay, so it has the security of a key, which will make it a bit harder to break as compared to the substitution cipher. The key in this cipher is actually the number of rows that we are used, or the number of columns that we are used. In this cipher, we have to write the plain text message on alternative lines across a page, for example, and then reading each line in turn, like read line number 1, then line number 2, then line number 3. To encrypt a message using this cipher, you have to write your message like in a zigzag format, and then start writing the letters of the plain text. Okay, let me give you an example to explain this concept. For example, you have a plain text given, and the plain text is defend the east wall, and you want to convert it into cipher text by using the Ralph's cipher or your Ralph's technique, which is a classical example. In order to do that, first you have to agree on a key, and the key is the number of rows. For example, I want to use total number of 2. So the number of rows is 2, and this is my key, this is my secret. So generate 2 rows and then write the plain text in a zigzag form. D, write D in the first line, write E in the second line, then F in the first line, E in the second line, and things like that. Once you finish writing the plain text, the next step is to convert it into ciphertext. And for that, you have to read this message line by line. So if you read the first line, it will give you D, F, N, T, E, A, T, A, L, which is under the understandable form. Once you finish reading the first line, read the second line, and that's it. So the cipher is read off by writing the top row first, which is followed by the bottom row, and it will give you the required cipher text. So you see here, we do not replace the letter with other letters. We actually jumble the letters. We actually change the positions of the letter in order to get the required ciphertext. In this example, I use the key 2. You can also use 3 rows instead of 2, like this. In that case, after writing D here, E here, F will be written here, and then rest, like this. Okay, you can use a key of 4. So it depends. The secret is the key, and the key here is the number of rows that are used for converting the plain text into ciphertext. Okay, well, beside from these ciphers that we have studied, we also have some other types of classical ciphers like root cipher, like visionary ciphers, and many more are available. So I hope you have an idea how the classical cipher techniques work, or how people use cryptographical techniques in the past. Thank you so much for watching the video. Stay tuned for more updates. Take care and goodbye.